Hello, hello. Hello, Frank. Hello, everyone. How's it going
Hello,
on you?
Denis. Hello, everybody. Yeah, all
Hello.
good. All good.
I'm good. I'm good. It's gonna be evening soon in Europe where Frank is based off, and it's yet to be the noontime for me in the east coast of the United States. Hope that and we have folks joining us from all over the world. Thanks everyone for coming and be with us today. The topic should be interesting. It's our primary focus is to chat about multi-tenancy, how to build multi-tenants applications using the distributed PostgreSQL architecture. Multi-tenant apps, Frank. How usually do you hear or involve or get involved in conversations about this multi-tenant architectures?
I think it's something everybody wants to do just because you cannot. You have to consolidate to decrease the cost, but it's always a balance. You want to consolidate everything to reduce the cost, but you also want to isolate them for security or performance reasons. So it's always kind of putting all together, but isolated from each other.
Mm-hmm.
So of course there are many solutions.
The multi-tenancy existed for a while, and I probably even heard about this multi-tenancy back in the days when I studied in at the university. But still, right now, yeah, I hear these conversations more frequently. It doesn't feel like that uh, microservices storm that we had in the past, because suddenly, like, we used to build, and I kind of keep remember building monolithic applications, and but that monolithic application was comprised of various modules. Every module was managed by different teams. It was all right to run it in production, and then suddenly we've got microservices, and right now we are just flooded with those microservices, etc. Multi-tenancy is ramping up, but still it didn't get to that level of hypeness that we had with microservices. But certainly we need to discuss it. That's an interesting topic, and there are many applications that
It
benefit.
also comes with the cloud, because if you have a software provider, you need a cloud solution, and then you have one cloud that serves a lot of different customers, and maybe a few big ones and many small ones, and then you don't want to dedicate an infrastructure for each customer.
Yeah, yeah. So there is a lot to discuss. We have 55 minutes left. At least, folks, you understand what the topic is going to be about. As always, we will walk you through some of the typical some of the typical solutions for multi-tenant architectures. If you use Postgres, we will briefly discuss them. Then, and also we will be doing a lot of the demos. We will be doing a demo for the open source Postgres, and then Frank will do a hardcore demo showing YugabyteDB, which is a distributed version of the Postgres database. But before that, feel free to ask us questions that are related to the main topic, and especially those questions who bother you, because this platform was also designed as a place for you to come and talk to us. So if you have any other unrelated question, just write it down in the comments, and we'll make sure to take a look at it, and we will do our best to address it during the conversation.
And questions or just feedback, even if everything works perfectly and you find all your answer in the documentation, still good to have feedback about our open source users, how they use Yugabyte, what they migrated to Yugabyte.
Yeah, the feedback certainly can be about Postgres and Yugabyte and etc. Or about, let's say, my haircut. How do you guys like my haircut? Eventually, yeah. A week ago, I looked miserably bad. Now I feel better. All right, so let's get to the news first, because we always begin our live streams with a quick update about something interesting that happened in the world of Postgres, YugabyteDB, and databases in general. Frank, handing over the mic to you, because you just wanted to briefly discuss one of the topics.
Yeah, and one of the topic around one of the latest blog we have, and then I will share it. There are not a lot of distributed SQL databases: Spanner, TIDB, CockroachDB, YugabyteDB. I think that's all of them. But they all do things differently, different architecture, sometimes different compatibility, and also a different business model. And we have seen, I think, this week or last week that CockroachDB decided to move completely out of open source. They were already not fully open source, moving out. And then we have some people asking question because it's not the first one. We have seen MongoDB, we have seen Elasticsearch, we have seen many software and many databases moving out of open source. And then people just ask, does it mean that open source is not a long-term business model? And I just wanted to highlight that yes, it can be a long-term business model if it is the goal from the beginning. And when Yugabyte started, also if you look at the past experience of the founders, you will see that they have built open source databases and like Cassandra, that then they come to a foundation, and so it's really in the spirit. And just mentioning that we have a blog post that answers that the reasons to be open source and why it's still a good business model to build a database today.
Yeah, generally this is Karthik's view and his take on this license change, and also he gives some update on our approach. I find this conversation interesting because personally, I think that we should not diminish or blame CockroachDB for what happened. That's their business, right? That's up to them to decide what needs to be done. Probably that was done for good reasons. Certainly, some of the people will be disappointed, but the good news is that if you're disappointed by one vendor, you can always find a replacement. But what I like, because we had this conversation about open source licensing again after CockroachDB changed the license. And I remembered another frequent conversation that sometimes I have in person or like when talking to someone online. Many people don't know, or they just don't pay attention to the fact that YugabyteDB is fully open. It's truly fully open source. And be like, yeah, okay, yeah. Usually the core database engine is always open, but there is always a product that sells like premium features like enterprise security or multi-cluster replication. And many folks, I saw how many folks were surprised to see that, are you kidding me? It's open. Yeah, YugabyteDB is open, and Karthik in the article explains why it matters and why it helped us in the beginning and why we are still committed to this license model. So you have options. But that happens, yeah. Some of the companies, and we know like many companies change those licenses. What else? As for the news, yeah, big updates are coming soon. So like we have a lot of things are going to happen in the world of Yugabyte in September. So folks, stay tuned. We are going to update all of you. We have the DSS Summit coming. Will be announced later. We have some other big features that are going to be announced, and a lot to come. You're going to learn a lot, and you're going to see a lot in September.
So September is back to school, but is also the right time to announce a lot of things and publish a lot of things.
It's back to school for you. But for me, like my elder son here, that's his second week in school. So the thing is that it's an off topic. I had a conversation with a colleague who lives in Europe, not you, almost a week and a half ago, and I said like, yeah, like yesterday was my son's first day of school, and she goes, "Are you kidding me? What does it mean?" Like, in the United States, yeah, the school season usually starts in the first 2 weeks of August. So there is no any one date when every kids go back to school, but usually it's between. It can be on August 5th, it can be on August 15th, it can be on August 16th, but it's somewhere in that range. I don't like it that much because I was grown and raised in a country where everyone goes to school on September 1st. But still, you just get used to this. Okay, going back to the topic. So September, they're back to school season for many countries of the world. There are a lot of the updates that are coming from Yugabyte. Also, if you folks, if there are any of you who is watching us today is going to Las Vegas next week, not just to hang out in the casino, but for the VMware Explore conference or Spring One conference, let's meet. I'm flying to Las Vegas next week to speak about GenAI, to speak about Yugabyte, and to speak about Postgres. Let me quickly share with you my session. Not this one. This one. So this is Explore VMware Explore. It's a good event, and they're going to be the Spring One track. Every Java developer knows what the Spring ecosystem does. And if you're interested, here is I'm going to do a live demo. We are going to build a generative AI plugin for the ChatGPT live plugin using Spring AI component, using Postgres and using Postgres PG vector extension. So if you're happen to be at this conference, or you are going to Las Vegas just to hang out in the casino, also go to this conference. But you need to pay for the conference. The entrance is not free. Right.
But
Any
they can also contact you and meet you.
Yes.
When I've been to reInvent, for example, I've met some people who didn't go to the conference itself, but were just there for company meetings or something. And it's conferences are always travels are always good to meet people physically.
That's an excellent point. That's an excellent point. So Frank, could you please double check if you have any questions in LinkedIn? Otherwise,
I am checking. We don't. Maybe we are not synchronizing very well because we have just a command saying hello, hello, and that didn't come on our StreamYard platform. So
yeah.
we monitor the two platforms independently.
Okay.
If the replication doesn't work synchronously.
Then how about moving forward and talk about multi-tenant applications? So let's start with a concept. I think that we can start with this window. So guys, I decided not to put together the slides, but at least I put together a few graphics that might be helpful for those of you who want to have some quick refresher on the multi-tenant approaches with PostgreSQL. But generally, Frank, like when we talk about multi-tenant applications, and you mentioned in the beginning that it's like the multi-tenant architectures became popular thanks to the cloud. And what I found interesting is that many SaaS applications, software as a service applications, are typical examples of multi-tenant solutions. Because let's say that, what are the examples of SaaS applications? Can you remember any? Do you use anything?
Not. There are lots of. I think all software vendors have a cloud version of it. So I think what is special with SaaS application is that there are a lot of different customers, and they don't want to maintain different schema, different infrastructure for each one. That's the main thing. They want to share something, not call each customer if they have thousands of customers and call them to know when they can upgrade, for example, or change something.
Yeah. I can name. Yeah, there are several examples. One of them is Shopify. I have this screenshot. Those of you folks, this is usually known by those who want to run their own businesses. Let's say that you already sell some product, or for instance, I can craft some nice tool. I probably can craft, some cool Yugabyte or Postgres related, giveaways, and I want to sell them on Shopify. You need to launch your website, right? You need to launch your e-commerce website, and that website needs to come with product catalog, with feedback from the customers. You need to handle payment. You need to handle shipping, blah blah blah. And Shopify is an example of a SaaS platform that lets, let's say, merchants or sellers or entrepreneurs just to go and quickly launch their online shop and their online marketplace, and everything will be handled for them. But they are a platform, right? Like Frank, you're talking, like down below. How does Shopify runs this infrastructure? Because they might have thousands and thousands and thousands, right, of those customers who are using their platform, and the platform should not fail. And I actually don't know if they how they implement a multi-tenant architecture, but there are obviously some of the engineering level articles that we can Google on the internet. But I thought about this as an interesting example, because if you think about a tenant, as one of the customer. Let's say that I'm selling some coffee. I just, selling some cool coffee, authentic coffee, and I want to sell it online. And let's say Frank, who might be selling beer from Europe, and I'm selling coffee from Florida, and we want to sell it. So we are customers and we are tenants for this architecture, meaning that somehow we sell different stuff, we sell different products, and we want to use the same Shopify stuff. But at the same time, with the multi-tenant architecture, all our data needs to be isolated. There is no any need for me, the owner of this coffee shop, to see what Frank sells, the beer owner, right? And the same for Frank. All this data needs to be isolated. All this data needs to be protected. But somehow, Shopify as a platform wants to run efficiently in the cost-effective way, because if they don't do this, then we, like Frank and I, will be paying much, much higher premium for using this platform. Hope this explanation from the business standpoint makes sense. Does it sound good, accurate, Frank, or you want to add anything else?
Yes, and you mentioned different things. You mentioned different regions, Europe, US, and there are
Yes.
some legal reason why you may do something different in the infrastructure for that. And yeah, and also performance that can matter. If I'm from Europe and I connect to US, the latency will be different. So when you think multi-tenant, you want to isolate something and maybe also run in a specific region. But that's a spoiler
Exactly.
for my demo after yours.
Okay, excellent, excellent. Then let's say that, okay, Shopify, we are doing that. And Shopify obviously uses the database. And again, I did my homework really bad. I didn't check like what database they use, and I did not. But anyway, this is just, we are brainstorming. We are taking different examples. But let's say that they selected Postgres as a database. Why not? And usually when you Google for Postgres multi-tenant approaches, you will be suggested at least one of these three options that I want to discuss with you right now. There might be different variations, but primarily everyone knows these three options. The first one is when you have just one database server running, and let's talk about Postgres as a single server. You have just one primary instance of Postgres running. There might be read replicas, but it doesn't matter. Let's make it simple. One instance of Postgres is running. And the first approach is so known single table multiple tenants. And in this case, let's say you have your database, let's say that logical database object that exists in Postgres. Then you might have some schema that can be public schema, it can be something else. And then within the schema, you have the table. And in case of our Shopify, let's say that we have a table that tracks all the product catalog. Let's say I have my own product catalog, Franz has his own product catalog, etc. And generally in the same table, they're going to be one single table that stores the products that Frank sells from Europe and that I sell from the United States. For instance, let's say that Frank's tenant ID, his own customer ID within the Shopify system is one. And these are the products, the beers, different types and flavors of beers that Frank sells. And this is the coffee that I sell. As an example, Frank, trade-offs. What's good and what's bad about this approach?
So there is one thing that can be good or bad depending on what you want. You have one table, which means that you have one structure for all of them. So it can be bad if one of those tenants need to upgrade to a new release of the application that maybe add or rename some column, but you have other tenants who do not want to upgrade to that one. And here you have a problem because you have a single table. Or it can be an advantage because if you have 1,000 of tenants, you probably want to upgrade all at the same time and not one by one. So really depends what you want to do, but the big thing is that here you share the same schema from an application point of view, the structure, and then if you upgrade, and you probably want to migrate the application to the new version online, because if you have a lot of tenants in different regions, you don't have a good time to do it. So you have to take care about doing the application migration in multiple steps. Like you will add a colon and everything still runs, and then maybe you will use the 2 columns, and then maybe later you will drop them. You have to take care about that. One single table can be good for operations, but some constraints for the application releases.
Yeah, exactly. If your requirements are very simple, let's say that, and probably if you don't have too many tenants, probably let's say 5, 10, or let's say dozens of tenants, you just store them together. It's simpler to build, it's simpler to implement, and probably if you have those tenants that, if those are not one of those Fortune 500 companies, then it's okay to update them probably at once. But also, your requirement might be that you want to update your customers in that rolling upgrade fashion, meaning that first you want to upgrade the first customer. If everything runs smoothly, then you upgrade the second. In this case, this approach might not work, but it exists because like there are truly, like as Frank, you say, there are scenarios and use cases when this is more than enough, and it's simple. It's simple. Even if you take a backup, you just take a backup and of your database, of this database, and that's it.
And you can also partition it. If you don't need that table to be one single table, multiple terabytes, that will be a nightmare to manage and have vacuum on it or create index on it. You can also partition it. One partition for each tenant or just for a list of tenants. So maybe you have a few big tenants that will have their own partition and all the small ones in another partition.
That's true. Yeah, we should never forget about the partitioning feature in Postgres. It's just as a spoiler alert for you, my friends. Frank and I, we are in charge for the experiences/workshop track for the upcoming DSS summit, and we were thinking like, should we create a workshop on indexing or partitioning? So the indexing obviously very well known, like everyone knows indexes, everyone uses, and you want to master the understanding. Partitioning is a lot of sort of a dark horse. People who are truly experienced, they know what the partitioning is and how to use it. But this is an excellent example that Frank mentioned. Like that definitely can help even here. You have that sort of one logical parent table, but if you use partitioning, like sort of that one big parent table logically also will be split into smaller partitions, into smaller tables. And but for you, for the application always queries just one parent table. Let's move forward. Security, actually, but security, I think that what you need to take care of from the security standpoint, data isolation standpoint, especially if you don't want one tenant to see or update data of the other, you just need to be very specific about the safeguards and permissions. You need to define all the roles and all the permissions properly, making sure that everything stays safe and secured. Another approach.
We have a comment, and that proves that we do not think the comments well from LinkedIn. So I will put a comment from Mike.
Okay, let's do it. Let's answer the question.
I copy paste it in our platform, and then we can show it. Like
I'm showing it. Plus simplicity, but seems like an operational nightmare for locking scenarios and overall customer data abstraction. For example, there is a real chance of accidentally deleting, exposing customer A. Yeah, that's exactly. It's as for the data isolation. There might be noisy. There might be noisy tenants, meaning that some of the tenants that generate a lot of the traffic and updates, and then that will impact the performance for the other tenants. That's why I think Frank mentioned the partitioning. I know that.
But you may have also log manager problems in Postgres with partitioning. Yeah.
Exactly. So that's to keep in mind. As for the data exposure, that's why in the end I highlighted that. We need to we definitely need to think through the roles, what roles you create, what everyone sees, what everyone can update, and that can be like very, very tricky and error prone to define, but it's possible. Anyway, my thinking is that I would consider this approach if I just have a few tenants, and probably sometimes I just need to even let them to see the data of each other. Like, why not? So that might be the case. In my case, I would say that if I were Shopify, I would not use this approach, because for Shopify, that's a huge platform where you have thousands of different merchants selling their goods online. No, it's like even partitioning of Postgres would not help this. It's
No,
like
yeah.
it would be nightmare. That's why let's see what else usually you would find if you Google for Postgres and multi-tenancy. Another common approach, and that approach is relevant for Postgres, I think, and Oracle and any other database. It doesn't matter. Again, let's say that you have your database instance, and then you have this logical database object. In Postgres, by default, we connect with the Postgres database in your connection string, unless you create something else. And then you create a dedicated schema for every tenant. Let's say this one, the blue one, this is this schema, and all the tables under that schema belong to Frank. And this one is mine. And here is a store my coffee products, and here is Frank sells the products like different flavors and types of beers that he sells. Excellent. In this case, this approach, I like this approach because it's just like my 5 cents, Frank, and then I will hand over to you. It better decouples the data structurally. I just creating a dedicated schema for every tenant, and as a developer, I know that if I, let's say, create Shopify, and if, let's say, the coffee owner, sign in with Shopify, the Shopify platform internally can easily connect me to my schema, because it's, just they will open a connection to the database and they will connect to this. They will just set the search path to the schema. It's easy. Like from the application development standpoint, there is not enough of complication. It's still easy to operate on the schema level. And from the data isolation standpoint, it's much better. It's like, let's say my data is here, Frank's data is there. And if Frank becomes truly successful and starts selling beer, let's say worldwide, he would become a noisy neighbor for me. But at least here is, we might come up with some optimizations for Frank, right? Like indexes, etc., etc. But from the security standpoint, I think it will be much easier to create roles. Let's say I will be given a role that allows me just to do everything I want with my data, but I will not be able to connect or do anything with the data that belongs to Frank. But from the operationalization standpoint, from the maintenance, Frank, what are your thoughts? Because I started thinking about indexing, even like if you create indexing, right? For instance, if you become very big, your business grows big, then some of the special indexes might be required for you, and those indexes will hurt me. And what's your thinking? Let's talk about this. It's all about trade-offs.
For me, I see the schema separation like with one table, we said that we can partition it. But if finally the goal is to read only one partition, then better to have this logical separation in multiple schemas. The advantage of having one table is only if you do some reporting for all the tenants, for example, but you can still do that with a big union hole there. So this is still good, but doesn't isolate a lot. You are just safe for application releases because you apply the changes on different tables, but you are still running on the same database, sharing the same catalog.
Yeah. And backups, right? When you do a backup, you will be backing up the entire database, right? Both schemas. Or
yes,
is it
yes, the real backup, the physical backups are and anyway will take everything. pgdump, you can list schemas like you can list tables. Schemas, a schema is just a namespace. Physically, it does nothing different. It is just a namespace.
And actually, on this diagram, I didn't make it clearer. Probably I need to update it. The database is also just think about it. It's a higher level namespace because when we connect to Postgres, let me quickly show this to you folks, because this is one of the confusion. This term is ambiguous in the database. We know Postgres is a database, we know Yugabyte is a database, but also within the database terminology, they have the databases, and those are just database objects. To make things clear, and this is what I show on my screen, that's my command line tone. When I'm connecting with PSQL to my locally running database instance, like this way, I'm using Postgres user Postgres. I'm not specifying any like database, but you see this one, Postgres. What does it mean? This is the database I'm connected to. If you execute this con info command, you are connected to the database Postgres as the user Postgres. So this Postgres database is a logical thing. And I think that if you run this command, \l, those are default databases that are created by the database. So their database is that logical database. It's another way how to group together different different objects like tables and schemas, etc.
What is different in the level of the schema within one database shares the catalog, even if they have different name, they are in different logical namespace, they share the same catalog. The catalog is per database.
So right now, if I execute the /d and command return me schemas, I have only just one public schema, but it's always possible to create. And this is, we have a DNS, I think. If you want to see, there should be also system level schemas. Oh no.
And you know why it is N?
Namespace? That's
Exactly.
yeah, like what you said, namespace and the namespace. Good point. Okay, so let's jump back to and finish this conversation. After that, we will show a few demos. So from the another approach. So this one might work or might not for Shopify, but I guess that probably it depends. It depends if they're using a monolith database, just one primary instance of, then it might be doable. But my gut sense is that they're running this in some multi-master configuration.
And
so,
also, we can mention that if you probably don't run thousands of schemas with thousands of tables, multiple thousands of tables in one database also, because they share the catalog. So if you have a lot of tenants, then may not be good to put all of them in one database.
Exactly. And Shopify is an example. They definitely have thousands of tenants. So this one is a database-per-tenant, meaning that, let's say that right now I have multiple those logical databases that were created for every tenant. Frank has his own, I have my own, and then under those databases, like we have the schemas that we need, we have the tables that we need, and this is probably the best decoupled approach you can come up with. Those are different, and you cannot, let's say, when you one of the limitations that you, at least there are several limitations, but one of them is with schemas, as you, Frank, said, if you want to run some request to join in or querying the data of both tenants, it's possible. Here, it's not. Like you need to use some third-party solution, because those you're connecting to one of the database. You cannot just have a PSQL connection to both databases at once, right? You're connected to one. If you query one database, one table, you cannot query the same table in parallel. But that's okay for the Shopify, I guess. So from the security standpoint, I also like it because you just make everyone owner of the database. I think that from the backupping strategy, it's also cool. And you know what else? Once, let's say, you need to scale, you just can take this logical database concept and let's say this one can run on one database server, this one can run on another one. But from the application standpoint of view, everything is transparent. The application, just connects, what's the IP address? That's the database name of this tenant. Let me get connected, and then boom, ready. Upgrades are also
the connection string is per tenant. Yeah.
We will show, right? Yeah, we will show that. And upgrades, we discussed before that if you want to upgrade the stuff in the rolling upgrade fashion, let's say that you are releasing the new version of your application, you want to upgrade, let's say, my shop first, me as a tenant, because I'm not generating that much revenue as Frank does. And they will first, let's say, upgrade me, change, the structure if necessary, etc., not touching Frank. And then if the migration of me goes well, they will upgrade you as well. So this is also an interesting approach. Anything else to add, or you wanna?
No, a demo.
Let's do the demo. Yeah, let's do the demo, and then we will. So the demo, I want just quickly to demonstrate this approach, multiple databases. So let me go to my terminal window. Yeah, I have just one screen right now. That's why it takes a while. So right now, as I said, we have just one, like we have this Postgres database, we have the templates, many databases are created for, and I'm connected to the Postgres database. But let's say that we decided that we are building Shopify and we would create a dedicated database object for every tenant. As an example, we can use the following two commands to create a dedicated database for, let's say, for the Frank's Morning Brew Company beer shop and Wild River Brewery. So this is mine. This is Frank's. So those databases are created, and if you execute the same \l command, you will see the databases are here. But we are still connected to the Postgres database. So what's next? Let's create the roles. And right now, before we create any tables, etc., let's think about data isolation and security. It's obvious that our two logical databases can coexist on the same physical Postgres server. That's why I want to make sure that Frank will not be able to connect and see the coffee and like the learn business insights from me, and I will not be able to do the same. I will not be able to connect and explore the data of his brew company. So I created the role for my, it's called Wild River role password. This is going to be used for my coffee shop. No, for the Frank's beer shop, and this is for my coffee shop. Morning brew role, the same password. The passwords obviously have to be updated. So what's next? And after that, once you created the roles, the most boring part, you need to think through. You need to think through the permissions. So what I'm going to do here, first, I'm going to grant the ownership for the to the Wild River Brewery database to the following role. So generally, I will be the owner of. I'm the owner of this coffee shop, and I will be owning all this database and all the objects that will be stored under it. That's for the that's for the beer shop. This is for the coffee company. Just we are making this role the owner of the database for the coffee company, and then we are just giving some privileges. First, I will not allow this. I'm reworking. I'm reworking. The connection for all of the roles, to both databases, and only then I'm allowing, let's say, to this Wild River role. This is our coffee company to connect to the coffee database, and I allow their beer role to connect to the beer database.
Maybe it's important to mention something for people who are not used to Postgres, but maybe other databases. In a Postgres instance that is also called a cluster, you have multiple databases, you have multiple users, but there is no direct mapping. In some databases, for example, in Oracle, in the pluggable databases, you can create a user within a database. Here, the users and the database are at the same level, but with your commands, you really map one to the other.
Yeah.
So
exactly.
you make those global users being a local user for each database.
Exactly. And now, as a result, let's say we can use this /c connect command. We will try to connect to our a new Morning Brew Company database, but we will try to connect using the role that was created for the beer company. So if you do this password, you are getting this permission denied. So it means that if let's say Frank's business is hacked, they know the password, and they will try to connect to and see the data of my coffee shop, they will not be able to do, like if they just know the password for this role. At the same time, if let's say I, the business owner of this coffee shop, let's say I want to connect to my database, I will be able to do that. I'm connected, and now you see that the PSQL session, we are connected here. We don't have any relations yet, it's obvious, but then when you will be creating those relations, let's as an example, every tenant in our Shopify implementation will have, let's say, a table like that, create table product, where you have product ID, title, description, price, and quantity, how many we have. And the same procedure needs to be, I think, repeated during the bootstrapping. When you create a new tenant, this is automatically created. So you would have that. And then as the owner, I will be able just to connect and to insert the data. And the cool thing is that this is my stuff and this stuff is not visible, let's say, to Frank. And then Frank can connect and do the same for his beer company. From the PSQL connection standpoint, when you will be connecting to this database as a user, let's say you specify, let's say, morning brew role, right? That's the username. And you need to connect to the database. And the database is morning brew company. You need to change it. Once connected, what's wrong? Password authentication, morning brew company. Yeah, I think that I did not use the best naming, because even I uh morning what's I'm looking for it. Morning brew roll. Morning, no, it looks like morning brew roll. Morning brew roll. And the database name is
It's
morning
Morning Brew CO.
co. Yep, it looks the same.
Yeah.
Password. Yeah, I think that I messed up with the password. So yeah, I'm connected, and this is how you would connect from the application standpoint. Cool.
Mhm.
So this is how you can implement multi-tenant applications using by
What I
creating.
really like with that is it's all declarative. So if you have a security audit, you don't
Mhm.
have to show some Java code, Python code to tell them, oh, look, it looks at which tenant it is, it connects to the right one. You can really show that a user that is authenticated with a password is mapped directly to a database.
Exactly. There are benefits. And now let's try transitioning to you as a quick transition. Let me show the final approach that I have here, because it's certainly related to Yugabyte. So we discussed that one. And then let's say when you start really having big tenants, or you need to think about scalability, high availability, then you can shard, right? You can use sharding solution, or you can use a distributed Postgres. In this case, you have several nodes, and those, let's say, tenants can be running on different places. So this is what Frank is going to look into.
Yes, and I will share my screen. I have started a cluster with 3 nodes there, and I have 1 node in each region, which are called region 1, 2, and 3. And I will run the same, but I will add more nodes in each region, because my idea, let me just start more nodes. I'm using a Docker compose that I have on GitHub that just can scale all that. My idea is that I want not only to isolate the tenant in different databases and not only with different connection strings and different password, I want to run them on different physical hardware, maybe different region, because I want my European users to connect to Europe and to be stored on Europe. But also, I don't want that one takes all CPU in a server. So I want to isolate them. Of course, with Postgres, you cannot do that with a single instance because there is a single instance. But with Yugabyte, we have many nodes. And here I've added some nodes. Yeah, I have 3 nodes in each zone. You can see them there. So with this, I can create a tenant and specify that this tenant will run only on region 1. And
Mhm.
because I have added three nodes there, so that I can be resilient there to one node failure. I'm in only one region, but I'm still highly available if there is a failure. And there I will connect and run exactly the same as you did. So I just copy paste
Okay.
it.
Okay.
I'm connecting here to one of those nodes for the moment, I don't care about which node. And I do exactly the same as you did. I just copy paste quickly all that. And
cool. It runs as
I have
this.
those two. Yeah, it runs. So I have the two users, I have the two databases. But now, before creating objects, I want to define where they will be located. And for that, we use table spaces. Table spaces exist in Postgres to store in different file systems. Here in Yugabyte, we use the same, the table spaces, but with an additional syntax where we map that to the cloud region. So I set a replica placement for the table space that is called region 1. And I want 3 replicas, replication factor 3, to be resilient to one node failure. And I have one placement block. Everything that I will create within this table space will go only on region 1. I will, because I have 3 regions, even if I don't choose them immediately, I will create the same for region 2 and region 3. And then I have a SQL mapping of my cluster topology, my cloud topology. So now I want to assign, for example, the morning brewery to region 1. I just set the default table space. Table spaces can be used at table level, even partition level, but I don't want to mention it in all my create tables. So I just set it as a default for this database. I can also set it as a default for the user. Not really useful to put the two of them because you already mapped one user to one database, but yeah, why not be explicit and do that?
Yeah, that's smart.
I do the same with the other one. So Morning Brewery Company is in region 1, Wild River Brewery is in region 3. And so this is just the default table space. With the default table space, you can also define another table space or make a mistake in your create table. What I want is to be sure that one user can create only on one table space. And that's again a grant statement. So you used grant statement to map the users to the databases. Here, I grant the creation of objects on table space region 1 to Morning Brew Hall. And I do the same for the other one.
All right.
And now I have set everything. I can create, so I connect to one of those. So
Yeah,
to
this
the
is
Wild River.
this is the beer company. Yeah, you're
Yeah.
connected to your shop, and like according to our story today, you're selling beer, and this is your
And I create
location.
the table there.
Okay.
Because I am in this database that I've mapped to a default table space, if I \d, I can see that this table space is on region 3. And
Excellent.
if I look at my cluster, let me refresh that. Sorry, I have to refresh multiple times because I'm connecting in round robin and not only to the master. And I'm not lucky. So you can see that I have some user tablets. In Yugabyte, we split the tables to tablets, but I have user tablets only in region 3. If I look at the table, I have the detail about the replication info. So this is inherited from the table space. The placement goes only in region 3. And we can check that all the tablet replicas, the raft leader and the followers, are in different servers to be resilient, but the 3 servers of this region. And we can check the IP address of each regions because we have an internal view. We have an internal function that tells me where I'm connected. So here I'm connected to region 2. I have created a table in the table space region 3. We will see that it's not a problem. I can run the DDL from any region. But let's list from YB servers all my servers. So those are the ones in region 3.
Okay.
So now I can insert data. I can insert data in this table, and data will be stored in region 3, but that's not sufficient, in my opinion, to be really secure and isolate, because I'm connected here to region 1, no, region 2. If I run my SQL statement, my insert in region 2, I will store nothing on region 2, but the statement will be in memory. So it's not fully isolated in the right region. I want to connect only to one of those nodes. And to do that, just because I want to do everything automatically, I have the load balance host that is set to random, which means that I can provide a list of hosts, and then I will provide a list of those 3 hosts in region 3. I select it with string at to get a list. And now I can use this list in my connection string. And because load balance is random, it will pick one of the 3 at random and distribute the load. So I do a gset, sorry, did I run? Yeah. Gset to set the variable, and I use the variable in my \c connection. So here, if I look where I'm connected, I'm in region 3. If I run the same reconnecting, I'm connected to a different node, but always in region 3. What I'm doing there is ensuring that I connect to the right region to be sure that there is no user data in memory in the wrong region. Here, I did it quite manually in PSQL, but with an application. If you use our smart drivers, you just mentioned that you want to connect to region 3, and this is done automatically in the same way, but transparently, querying the server region and the YB servers.
Also, it helps from the performance standpoint. Let's say those of probably like most of your customers who are buying from you as a merchant on Shopify, they will be buying from Europe, and they want to connect and they want to put an order faster, right? They want to connect and they will be connected to those database modes. So you achieve this data isolation, but also you help with performance. And another thing which came up to my mind while you were doing this demo, Shopify is a global platform. And also this approach already solved a bunch of the problems they need to comply with in Europe, like where you have general data protection regulations, GDPR, because all of those customers who are going to buy the beer from you, you're going to store those transactions and orders, and you want them to be stored not in the United States, you want them to be stored in Europe. And this is automatically handled by the database. It's like the GDPR is solved.
And without procedural code that can fail, get bugs, this is fully declarative. Just declaring table spaces and all that. So now that I'm sure that I'm connected to the right region, I can insert some data. So I'm running the same insert as you did with a mistake, which I made on purpose. I will explain later. So first one was not good. I had a syntax error. I have the full one, so I inserted one row. If I query my table, I can see that I have inserted in product in the database I'm connected to this file Ale with citrus note. Okay, now I want to prove you that I have no data on
Rajesh,
and
Rajesh on LinkedIn said that, this was much more informative. So
cool.
Good.
Because for the moment, I didn't prove that it works. I just declared all that. But to prove it, I will connect to each of the nodes in my cluster and just do a grep, go to the data directory, just do a grep of some data, citrus, there. On purpose, I didn't encrypt my database. In a production database where you enable encryption, you cannot just grep data like that. But when it is not encrypted, you can see it.
Oh my God. You're going deep in the woods. All right.
So for the moment, because I inserted only one row, very small, and because we use LSM tree, it doesn't go to an SST file. It's still only in memory in the memory table, but protected by write-ahead logging, the walls. And this is why I have a copy of my data for each tablet peer, the leader and the followers, and in the wall for each of them, but only for those nodes that are in region 3. You can see also a log here. And this is why I did this mistake on purpose. By default, we log the statements in error in the Postgres log. And the statement has some data. It can have the username. So it's not only about storing the wall and the data in specific region. You don't want to see any trace of a log in another region. And that's the reason why I want to connect. That's one reason why I want to connect to the right region. The other is, as you said, the latency. I don't want to be in Europe, connect to US to finally write in Europe. But from a security point of view, you also don't want any trace in memory, in logs, whatever elsewhere. So here, I'm sure that I have my data only in region 3 for this tenant that is mapped to region 3. I can quickly flush all those LSM3 and grep again. Sorry, I flushed again. That's not a big problem, but I grep again. And you can see that in addition to the walls, I have SST files. So this is where the data is stored in a persistent way. Okay, so that really maps a tenant to physical nodes. So this is the additional level of isolation. You want different physical nodes because they are in a cloud data center that you are allowed to store this data. And also, you are guaranteed that even if one tenant is running away, taking all CPU, network bandwidth, I/O, it will have no impact on your other tenant because it's completely different infrastructure.
Good point. Good point.
I can
yeah, we have
do something else. Yeah.
Let's yeah, we already
Let's see
run out of
first
time.
if we have questions. If we
Yeah,
don't
yeah.
have questions, I can show something just in 2 minutes, just to mention that the same technique can be used for all multi-tenant solution, even the partitioning in a single table.
Yeah, we have a feedback from Pete on LinkedIn. Let me just share it with you here. And guess what the feedback is?
Cool.
No, clever.
Clever.
Well done.
Yeah.
Yeah, well done. Well done. Show it.
Compared to some other databases, like, for example, Oracle, we don't have a resource manager to isolate the CPU resources. Well, we can do that with C groups, but because we can scale out to multiple nodes, it's so easy to isolate to physical nodes, and then we are sure that we have the right isolation.
And while you're like before you show this last, let's show that thing, and then I wanna briefly I googled for Shopify database what they use because today we discussed Shopify.
So in the case where you have a lot of small tenants, but a few big ones who pay probably more, maybe you want different strategies. So one database for the big tenants and put all together in one table for the other one, like the first solution that you show. I create a database for all those ones that I call multi-tenant. I connect to it. And here I create the same table, but as you mentioned, just adding a tenant ID there, and I put it port as of the primary key, so that I can partition by list.
So generally, you do this mix and match, right? The database can support various multi-tenant approaches. Some customers are stored physically separate,
exactly.
some together within the same table. That's good. Yeah, you can
So
mix
for
and match.
this one, I create one partition for multiple tenants, the tenant 2, 22, and 222. And I put that in region 3, and I'm just showing that I can do exactly the same. I've just mentioned that this partition for this list of tenants go to region 2, and that's all I have to do. Now, to insert in a specific tenant, you can see that I used a current setting, so a local session parameter. So the application can set the tenant ID. And if you insert, you don't have to mention the tenant. You have set the tenant of your session. So it's the default for the tenant ID. Then it goes to this partition, and then it will go to region 2.
Yeah, excellent. Yeah, another
Let
option.
me just grab quickly. So I inserted the bush beer, my favorite beer, that is amber. And if I grab for amber, I can see those hosts. So 4, 7, 11. And I guess that those are in region 2. 4, 7, and 11. Those are region 2.
Excellent.
So this double space mapping can be used for partitions, for schemas, for databases. It's just an additional level of isolation that we can do.
Exactly. Excellent. Many options. I think that there are even more exotic approaches that some of the guys might use, but still, those are the primary solutions that you can keep in mind. And
so
as
did
long
you
as
check what database is used by Shopify?
they use MySQL and they use sharding. Obviously, that was my prediction. They have to shard this somehow. They have to distribute. They might use how it's called Veritas, or like probably like some sort like the Planet Scale. The Planet Scale is built on. It might be of that magnitude. The difference between sharding and distributed databases, it's just a different aspect because YugabyteDB is fully distributed. It's easy from high
the
availability.
operations are different because when you shard, you have to shard to multiple databases. You have to protect each of those databases. So MySQL, it's a monolithic database. So you need a standby database or 2 standby database for each of one, and then the infrastructure becomes quite complex. And also, if you want to reshard, for example, you want to move a tenant to another region just because they were not isolated and they want to be isolated. If you do sharding, then the resharding operation is quite complex. You have to copy data. So to your multiple databases with multiple physical standbys, you will probably add, for something that must be highly available like Shopify, you will probably add some logical databases to do this change, and then that becomes quite complex. Where with a distributed SQL like Yugabyte, I can just create a new table space and change my tables to a new table space, and it will be transparently moved there.
Yeah, sharding is necessary for distributed databases as well. Meaning, like we also shard the data, but sharding is just the basic stuff that needs to be done if you want to distribute this stuff across the cluster. But then, what you do on top of that, how do you handle, let's say, distributed transactions? How you do upgrades? How do you handle fault tolerance? How the cluster nodes communicate? Because if the cluster nodes don't communicate to each other directly, then there needs to be some coordinator that sends heartbeats and blah blah blah. So generally, anyway, the cool thing is that the Shopify team understood that they need to go beyond the single server capacity, and it's not a surprise that their multi-tenant architecture runs also at scale. They use this sharding. I don't know the details. With YugabyteDB is also, as a Postgres database, distributed Postgres database. Once you need better availability, scalability, etc., as Frank showed you today. And it's very easy from the operation standpoint to define different tenants, to place them in different places and comply with GDPR, be low latency, and etc. And just write the apps like you would be writing for just a single server Postgres instance. No differences. It's all transparent for you.
Okay, so it's still one global database. So if you have a use case that needs to reach from multiple tenants with a specific user, probably more secure, then you can. You don't have to connect to multiple databases and gather the data. So you have also the advantage that you can isolate, but you can also run a global query on all that.
Exactly. All right then. Having said that, thanks Frank for running this tech talk. I enjoyed. I think that the folks who joined us today, thanks for sitting through the end. I hope that you liked it. If you need any of those, let's say like I showed you my GIST, my GitHub, notes. If you want to get them, just send me a note in Slack or on LinkedIn. You will get it, and just keep building applications that scale and never fail. Bye-bye now.
Yeah, perfect. Goodbye.